Okay, well, good morning, everybody.
Good morning.
Good morning.
To start off with, to carry on from what you heard from Pete, I'm gonna take a little deeper dive into the LED light itself. And Pete was 100% correct on what he was talking about, the up and the down on the sine wave. Because when we look at power, we look at AC, the sine wave, that's where he was telling you it was up and it's down. But it's not really a positive, negative, it's back and forth. When we look at our LED lights, most all the lights that you see now, other than the ones that are probably in the last 2 to 3 years have been commercially come out, they'll specifically say full wave or half wave. If you bought them before that, the majority of them are all half wave lights. And what that means is, this is the AC version of it right now, okay? And when we're looking for DC, basically what we're doing is we're taking this out, this bottom curve. And we're only using this on there. And where people also mentioned it was a pulsating DC, now you can see the pulsations. Okay, 60 times per second is hertz. The hertz portion of it is, that's what's in the US. Okay, when you see the sine wave like this, that's where the flicker comes in, i.e. half wave. When we say full wave, what we're doing is, in lack of better terms, we're flipping this one up here now. Now we're making it a full wave. And you can see how it is. Now, is it constant? No. What it's doing is that we just double up the pulses. So your eye will never ever notice it, and it'll look brighter. One of the downsides to doing this, if you do it with an older set of strings, they engineer a string probably for half wave at that time, if it's an older string. If you run it or monitor it to make it go full wave, there's a possibility that you could burn your LED light out. Or might not burn it out, but it's going to shorten the life of it, because it just was not spec'd out at that shape. And that's kind of how the full wave and the half wave works. Okay, now that you've seen it kind of drawn, basically this string here is, this one right here is a half wave setup. And how you can kind of tell that is if you look at the glob that everybody's so happy to tell what it is, this is where your rectification is actually happening. And right now you can tell that that's a half wave, basically because of the size. Now to give you the opposite look at one, here's one that goes to a rope light, and you can see that glob. And you see the difference in the sizes. So we can set these down so you can kind of see a difference in the sizes of the globs that you'll see right there. Kind of lay them out. Okay, with that, glob's a good term, but as far as I've known in the last years, glob doesn't really explain much to me, and I want to know what's going on. And that's where this kind of, my study kind of come in. What we have, when you have a single wave, or single wave, half wave modification, is basically you're going to have something that looks like that. What this is we have two resistors, and we're going to have the diode. The diodes basically, they're going to look like this guy right here. And what a diode is it allows, like Pete said before, it allows power to go one direction only. In that one direction only, that's where we're picking up the half of the wave. Okay? And then on a full wave rectification, there's a couple ways it can be done. This is a half wave, this one here. This is a single diode that will create your full wave potential. Okay? And then the other way is, let me open this one up. Oh, so you can see what part I got. It's nothing real special. It's from Radio Shack. All you want to make sure when you buy a diode is that there's a PVI, peak voltage inversion. What happens, what that means is on your AC current, it's always going to try to bring it back. You want to make sure that that back doesn't get backwards through on when it goes to the diode. So when you look at that, you want to make sure that on your diode that it's well above the voltage. And another thing I should explain too, well, let me get to that after that. We'll open these and show you what this looks like. All right. What they'll do is we're going to form, it basically looks like a box with the diodes. And then you'll have the power coming in from each side, and you'll have power going out. And basically what we're doing is we're taking both sides of the sine wave and we're flipping it, or we're making it a full wave for the power to be used. So when it comes through. And at this point in time, I could make a real nice joke about some of Pete's family life, but we're not going to go there. But that's kind of the diode. Okay. So, and what you're seeing is that's a wave, a half wave or full wave. And depending on what glob you have, is how you do it. Now, an important thing is you hook your lights up, and you're hooking them up, and you're going to go, okay, they're not lighting. The first things you want to check would be is you got power to your lights. And what can you check with that? And it would be a simple induction testing tool, which is made by Clack. Greenlee makes one. Just about everybody makes one. The Christmas ones. This is the Lightkeeper Pro. At the front of it, it's the exact same thing. It'll do the same, but it beeps. The only thing whatever you prefer. I prefer this because it's telling me exactly what I want, and it's more made for that process. When you look at it, what it's going to tell you is we have power to the light string. Okay, so now we know we have power going through because it's lighting up. Okay. As it lights up, so we know we tested this string and it lit up. Now the lights aren't lighting up when they go through this cord. So what we're going to do is we'll look at this. Now I brought this one out specifically because if you guys want to look at this, what's missing? What do you not see?
The wart.
The glob.
The glob.
The blob's in the plug though.
Yep, exactly right. If you have a Martha Stewart or a Lowe's type lighting, they say that, the globs are in here. And if you're like us and you're using the LORs, the Lightoramas, the D-lights, any light controllers, and you go to dim or shut off or trans in the lights, if you have a Martha Stewart, you're going to have problems. There's nothing wrong with the lights. What they have done when they made the lights is actually put a capacitor, what they call it is an amplifier, but it's basically a capacitor inside of the plug-in. So it's always keeping power. Why they did that, as you can see right here, is why they did it. If with this dropping and it's cycling, they put the capacitor here so it keeps it, instead of making this go like this, and made it actually smooth it out. If you put it on an oscilloscope, you actually watch that line, it'll start to flatten out. So now you have true DC power. That's what the thought is. But when you drop or you fade, guess what happens? Your DC stays the same longer, and now your timings are way off. That's goofy. So the best thing I've seen and I've read is not to use the Martha Stewart somewhere where it's static, or they're just on off. Then you should be good. But there might be a little lag time on the things. The other thing I found too is some of the controllers, what they have is a gateway. Okay, your controller, your triac kicks on, it kicks off. That gateway is not, is bipolar. What it means is it goes both directions. There's not a fence that goes both and it stops from coming back. This is bringing up to us to the next subject, is that if your gateway, mine specifically are LORs, they don't have a gateway in them. So when it goes, it'll feed backwards. What it'll do is feed backwards the other way. What happens is, when we have an LED light, we're only using so much current to light so much of the light bulbs. Usually it's a 2 to 3 milliamp signal or voltage, or goes through the system. As you do that, 2 or 3 volts goes through there, you're going to use so much up on 10 or 24 bulbs, but there's always a little bit left. That little bit left is basically, we're with using these diodes and resistors, we're kind of holding it back. Think of it as damming. When we shut the light off, that dam has nowhere to go, so what it'll do is it'll feed back through your controller or light up some other things. Where it becomes really critical is you get 50, 70 strings out, 80 strings out. Now you can understand where we're just adding that much more into our dam to release that water off somewhere else. Okay, now, one of the guys that come up with, that I've seen off of Planet Christmas, is what they call a snubber. Basically, it's a plug-in and a 480K resistor, and usually like a half watt. I don't know if I go to a quarter watt. I think I'd use a half watt size on it for size of your resistor. But simply to do it, I might get this off without cutting my finger. What you would do is place the resistor right across like that. Okay, that's what you have a snubber, or you'll have a snubber that goes through there. And again, so you can see it, it just kind of goes across like that. And you would wire it on, plug it in. On the other end, take some hot glue, fill it up. One of the things with hot glue is that right now I'm going back and forth with Bill Ellick, is on hot glue on the cold, how it's going to react. I'm from Montana. It's really, really cold. Hot glue, anything you do with thermoplastic, when it gets really cold, it becomes very brittle. It loses its traction. I think it'll be okay, but I haven't tried it too far yet to see what's going to happen. So, but if you're out here in the balmy West Coast, you'll be okay. Because usually it's not going to get cold enough to where it's going to lose its adhesion or lose its.
So are you filling that plug with the hot glue? Is that what you're saying?
Yes, I am.
Okay.
I'm filling that completely up, and then basically what you will do, I've heard guys say that if you get like 2 or 3, usually not too much of a concern, but if you go out to the max, 40, 50, 60, somewhere in there, if you go out to the max, then the concern comes in. And all you need is just one of those at the end. Another way of doing it is the plug-ins, the scented plug-ins. If you think about it, what a scented plug-in doing is, what it's doing is it's heating up the scent, it's giving off smell. What we're doing here, why I said a half watt or a quarter watt, when I meant that is that this has to dissipate heat. Basically, it's going to give it a place for that dammed up electricity to go to, instead of going back to the controller. So you'll get crisp, sharp ups and downs and shutoffs. So that's what will work there. There's a few other guys that have done other things. Some guys have put incandescents or an in-can, just cut one and plug it in at the end. And what you can tell is that what it does is when it goes back there, it's going to try to heat it. It won't light. It might, but it would get so dull I don't think you'd notice it. But it's just trying to get rid of that excess electricity going on.
But that's not going to help like the Martha Stewart string at all.
No, because of the capacitor that's in the line. When you have something like that, we've built up too much current, too much dammed up electricity.
What would happen if you disabled the capacitor in there?
You could, but I don't know what it would do to lights, and frankly I haven't done it. From me to you, I just stay away from buying Martha Stewart lights.
Well, what if you have a bunch already?
If you have a bunch already, there's a guy by the name of Z-Man or Mark. He will buy them from you. So you can go ahead and talk to him about that. No, usually what I would do is, there's a way you can modify them, and guys have modified them, but now you're getting very complicated, because now you're going to have to, is a lot of the Martha Stewarts that are actually wired in parallel, not in series, and that's an issue. What I mean by that, thanks for the question, if you look at this string here, you also see something that's kind of funny with it. It's going to have three wires.
4 wires.
Yeah, it's got 3 wires going into each one of the blocks. And what does that do for you? That would be your next question, right?
Yeah.
Okay, what it does for you is the difference between series and parallel is magic. Okay? Now, when you get into wiring, or you get into, which I'll cover in a little bit, creating your own blobs, when you get into creating your own blobs, this is an issue. Because now they're basically seeing 3 volts. Anything we feed it, we're taking it off kind of in a packet style. As it goes down line, and we're ending up at 0 is what we want. What this one does is we could feed it too much, and you'll burn what we like in the industry to say is a D-LED, dead LED. But that's basically, that is a parallel versus series. This string right here, this is a series string right here.
One big loop, in other words.
Right, one big gigantic loop. Okay, that's a series. Now, what the difference is with series, which I'll show you guys so you can see it. What's going to happen when I pull the one bulb?
It goes dead.
They all go out.
Yep. Now we created D-LEDs.
A whole string of them.
Whole string of them. But that's series versus parallel. So if you're going to do any modifications, what I would say is this one, be a little more cautious with how you do it and how you go about it. And if you do have questions, you can call Pete. He will answer them for you. Or you can give me a call or send me email, or if you're, which I'm sure probably everybody that's seeing this is going to be on Planet Christmas. If you go to Planet Christmas, my handle is DSE. Okay? And you can PM me or whatever. I love friends, so become my friend on Planet Christmas and we can chat back and forth. A lot of the stuff too, understand, I didn't do all this. What I've done is I've studied all this. And this is from guys that are out there banging their heads with these lights all day long. And this is where it's coming to, where it's coming from. I've kind of done some implementations on different things, but hey, whatever works. Okay. Now with the lights, when you also see some of the battery packs, and that's typically what you're going to see in a battery pack. Okay, let me show you so you can see that. In a battery pack, what we'll have is basically you're going to have a little circuit board, and the batteries are flowing out. Now, when I say you have a battery pack or battery lights, almost always, always, always are going to be in parallel, because it's giving us 3 volts to work with to light our lights. Basically, each one of our lights is normally 2.5 to 3 volts forward at 20 milliamps. But the easy way to do it is 15 milliamps. What that's saying is it's providing 3 volts out at maybe 100 milliamps. So each light is seeing 3 volts. And then we're taking the milliamps and we're dropping it off until we get to the end. Make sense? Whereas we do a regular AC conversion to DC power, we're shooting out a voltage of, like with this set here exactly, I think it was 120 or 140 volts DC that I'm sending down line. But I'm sending it in series. So my first one's taking a bite out of it, the next one's taking a bite out of it until we get to the end, so the apple's all gone. If we put 2 apples and send it down line, what happens? We have D-LED.
Yeah.
And when they go D-LED, it's not like, they're gone. And you won't even see much excitement. All you hear is a little pop. Trust me, I popped a bunch of them. So that's kind of the difference you're going to see between them. Now, in maintenance to any LED lights, you can actually take, probably not a standard, maybe a little higher end. This is a Radio Shack one. It's like 30, 40 bucks. Meter, multimeter. And if you look on the front, it's going to have a little sign. So I draw this right. It's going to look like this. Okay, this is a diode sign, specifically for LEDs. So when you see them in engineering drawings, this is what you'll see. It doesn't necessarily have to be LEDs because our diodes or directional diodes will have the same kind of drawing to them too. Now, what I've seen, not that you'd run into it much, is you might see a drawing like this, and they'll have like this on it. Or they'll have like a fan-looking object above it. Basically, it's telling you it's a light. Okay? I doubt you'll ever see this in any of these, but that's what it looks like. Okay, now that you know that, you're going to see the tester. And you can, when you look at it, you can see it on there. It's very important that you have that on there, because this is what's going to tell if your LED lights are working or not. Okay. I will put it down on the table here so you all can see it close. And you can probably see the markings on the top. Some of the older ones, if you have an older one too, and it's got an LED, you're probably fine. You just want to try it, test it out and see. You know, and this is an older one I have that I've kept for a long time. This has been a good one for me. But you can see the marking on here. It says LED or diode tester. Okay. What's really slick about this is you can put on a diode tester, grab yourself a standard LED light, and then you just hook it up on each side and make sure you get something real important corrected. Okay, now this is kind of hard to see. I'll put it down here. First off, I need to explain there's a cathode and anode, positive and negative. If you look at the legs of the bulb, or you pull one apart, you'll see one's shorter and one's longer. It's basically telling you a positive, negative side on that. Because remember, LEDs are not like incandescents, they are directional. They got to be lined up, positive, negative, positive, negative. And that's how they're going to work. When you go to fix one, say if you have a fixed string and you cut it out and you flip it, or you get a replacement and you flip it and they don't light, and you're wondering what's going on, more than likely you could have got turned around. So my suggestion is, it's really easy to get these confused, is that if you pull one, or if you take a string, is take the side that you find is positive and mark it with a white pen, black marker, just something so you can see it. But now, when you hook this up, guys always ask, well, what's the forward voltage? I beg you to find out the forward voltage on that by looking at it.
Yeah.
You won't find it. This works with all your lights. If you look at the meter, you guys want to see it, the wow is it's doing something. What is it doing, Alan?
Kevin.
I'm sorry.
It's got a reading of 1.8.
Okay, and what does that mean? Okay.
That means it's passing.
Because I am going to ask Pete, he'll probably answer it right, so it won't be nothing hurt.
Well, I think it's measuring the resistance. No?
What it's measuring is current, because you're not looking at voltage there, you're actually looking at current flow, because to make the LED work, it has to power the junction, and you do that with current. You don't typically do that with voltage.
So what that told us was what? That it was 1.8 volts that's going to take to start this LED light.
Oh.
Okay? Now, there's something very critical that you need to know about that. that it says it's 1.8 to start it, it doesn't mean it's high end. It just means it gives you a starting point. That's why when you see in there, everybody always says you have either 2.5 or 3. I would not go past 3. In any Christmas lights we have, you're not going to see past 3. There are some out there that are bigger, but they're not typically going to be in Christmas lights. What I would say is you're better off to start at 2 into 3. Somewhere in that zone you'll see them. And that'll come more into play when you see this, when we start breaking LED lights down. And we'll kind of go through that here in a second. I know Mark's been after me because Pete talked on for so long. Okay, and then once we kind of talked about the meter a little bit, and if I got the one right here, let's see if I can get this to work. Again, the positive and negative is kind of a problem. Okay, can you see that?
So that meter lights it up.
Right.
The other meter did not.
No, it's the same meter.
Oh.
But what is it telling you?
So it was able to push a current, so the current that tests it is actually high enough that it activates that LED versus the green, which is going to be activated at a different current.
Right. So what it's telling you is this one's probably going to be more like 2 volts to get it to cook off.
Because you were saying that the forward voltage before was 1.8 that Kevin was reading off the meter.
Off the green. So we know that this is starting off less than that. And this one didn't even light. So this one's probably going to be 3. And I've got a chart. And again, call me, email me. I'll give some to Mark and to Kevin. So you guys, if you want some, you can have them. So it gives you kind of a diagram of you got a green light. It's usually 2.5 at what you'll see.
I thought most of the LEDs were pretty much the same, but what you're saying is that they're vastly different.
Hugely different.
Okay.
One manufacturer I've seen has 172 different LED lights. What they'll have is you'll have a round top. And Pete, if you watched his demonstration, you look at the spec sheet, it said a cap, straw hat. When you look at it, it looks like a straw hat. This is a round top, okay? This one's, where do you go? This one's conical. And what it does is it has a little concave on the inside. What that means is it gives you directional lights. And that's where a real disparity comes in. Because you'll see lights where they'll either be, I think it's 30, 60, and help me out, Peter, 90.
Well, you typically will go from 120 all the way down to usually about 8 degrees.
Yeah.
So, from spot 8 degrees being your spot, 120 would be your maximum flood.
Right, and that's what happens. And what you'll see when they call these the strawberry LED lights, and all looks are not the same. So if we pull one apart, oh, by the way, this one's dead anyway, so I'm not killing anything new. So
that was our door prize.
Yeah, one of them.
That was Mark's.
Yeah, there we go.
Okay, once I've got it apart, and you look at the light on the inside. Okay.
It's tiny.
Yeah, real tiny little guy. And that's all it's taken, but you can see the color, but don't ever trust the color of the plastic to be the color of the light. What determines the color of the light is the material that is sacrificed as an electron passes through it and jumps to the other side. Okay? I've got a chart too, I'll give to Mark and Kevin, and you guys can look at that and it'll show you how it was developed. But that's the difference. What the huge thing is with this is just giving us a diffuser. Think of like a light on the ocean, that goes around, lighthouse. Mm-hmm. Basically what they've done is they just cut multi-facets on the plastic so you get a better light, okay? But it's a lot smaller. That's why right now you've seen 4 different sizes, and we haven't even hardly touched anything. And I'll show you these 3 different examples. Once Kevin gets his batteries charged to work right.
That's right.
Okay, and then you'll see the different colors too, and not necessarily, will these colors, the lens will be a different color than the light. It could be white, all it's doing is shining through the lens. This is one that I burnt out earlier. You can tell there's different colors to it. And when you do burn out lights, I will strongly, strongly, strongly recommend that you clip off the ends. I got one here. And even if your neighbors, friends, relatives, grandmothers, in-laws you don't like, ex-wife, go by, clip all of their plug-ins off. Because
So you've just got the plugs, you don't have the warts.
I don't have the warts, and some guys brought up, says, well, we're going to save all of our warts. I'm here to tell you now, do not do that. Their manufacturing process is very poor at best. Now, if you're buying some from CDI, Lights in the Sky, the other big buys they've had, you probably get a pretty good chance they're decent lights. What I'm saying more is if you buy them from Ace, Home Depot, Lowe's, the local grocery mart, their quality is not even questionable. It's probably not even there. Because remember, when you look at these lights, and it'll say in bold writing everywhere you read on it, they are for only, what, 90 days use. Okay, that's in manufacturing and engineering diagram, if you will. So they're thinking you're going to use it for 90 days, pull it off the tree, chuck it in the garbage can. So they're not worried about putting a wart, a glob, the wave resistance to make it really high quality. I didn't bring any with me. I've cut 4 of them apart. I've actually seen the wart where when you have the wart going on the inside, this is basically the wart, and then you go back out to your string. I've seen where this wire coming in to go to a rectification was stuck in the plastic like that. And I've actually seen some where that was actually stuck outside of the plastic. I thought it was something wrong, but it's just a manufacturing process. Now you understand why I'm saying not to do that. Now there's another thing too. When we do these, we depend on, we're basically, an easy way to think of it so I don't overcomplicate it, is we're damming up electricity and we're only letting so much go through that we want to use, okay? So when we dam up that electricity, it comes through into our diode. So I'm guessing, Pete, you correct me if you think I'm wrong, but I'm guessing they're using this wart as a heat sink. What that means is they can drop their resistor down to a quarter, half, you know, somewhere in there, wattage, and they'll let this get warmed up. And what we're doing, okay, when I say that, when I say wattage, when I dam it up, when I dam this up through the resistors, first off, it's going to go through the diode. Diode's going to change this to DC, either full wave, half wave, whatever you want. But when you get through, we need to dam it up so we're only let so much power go through for how many lights we need. And then as it goes through, when the power goes out, there's always going to be that little bit of electricity left behind. What the resistor is doing is it's allowing it to dissipate. That's where wattage comes in. If we've got a bunch, as Pete was saying, currents pushing your electrons through, if we've got a bunch hanging back here, it's going to increase our wattage size. I've done a little spreadsheet, and that if you call me to talk to Mark or Kevin, I'll get it to you. And all you do is plug the numbers in. You tell me how many lights, how much, and it does all the math for you. If you like, there's a whole bunch of internet sites. I'll do the same thing. The only thing that's confusing on them is they're in Pete's world, which is scary.
Pete's world.
They will work on 12 volts, okay? And that's nothing against Pete, he's just kind of...
Am I DD?
You're DD. Well, if you listen to Pete, he says, first off, we got Clapton, and he's showing us how we're gonna get DD now. So, I'm not really worried. Okay, but as you go through, they'll do this. Your calculations are set on 12 volt. Why it is, because most of the sites up are robotics sites, or they're car sites, or they're engineering sites. They're not Christmas lighted, addicted personality sites like us. So what you'll do is, there's a few of them, call me, I'll get them to you, that guys have created them, whether we're using 110. The only thing what you want to do is, when we go 110, we're doing DC, 110 is in, or I'm sorry, 120 is in RMS. Which stands for what, Pete?
Root mean square.
What that means is they're saying, on an average in 60 seconds, this is what you're going to see, on an average. Now, what did I say? We're taking the dam, we want to stop it up, and Pete also mentioned how really sensitive it is, how much power we let go downstream. So, what do we need to do here? What if it rains and floods in our dam? What do we want to do?
What's the note?
Yeah, so we want to make sure we know what? The peak voltage, okay? Here's a number that you want to write down, take it home. 1.414. Okay, this goes times your 110, and I'll simplify it for you so you don't have to write that down. If you do any of the calculation, this is your new volt setup. It's 170. Because now we're figuring on peak. Okay?
Wow.
If we're a little under, we're okay. If you're a little over, what do we have? LEDs. Okay? That's what we don't want to do. Okay, and that's where the calculation comes in. And once I got over this, I'm telling you, you can create any one you want to create. What I've done, and basically it looks for this program, is I've created my own string here. Okay, there's 24 lights on this string. If you see any setups, what you're going to see is 35, 70, and 100. Okay? When you look at circuits, that's 35, you're going to have, I think this one's 50. But this is a different one because it's what? Parallel. Okay. This will throw it off. When you have the series lights, you'll see 35, 50, and 100 in there. They're going to have 2 or 3 sets in there. If you create a full wave rectification for that light set, how they'll work is we go back to the sine wave, up and down. They're going to have 2 blobs, one at the back, one up here. Okay. First blob is taking the top of the wave, using the light itself. The back blob is taking the back of the wave, lighting it this way. So now we full wave rectify it. We took all the waves, we flipped them up. What's going to happen now? We're going to have beautiful lights on this, bright and beautiful. We're going to have no lights.
Dead.
Because remember, it took the bottom side. Easy cure. When you go through your string, you're going to have 2 wires coming in that's going to break into 3. They're going to wrap. You find the center, you're going to have 2 wires. All you got to do is plug in your full wave. If it doesn't light half of it, cut it, flip it, and you can either solder, crimp, or put it together. Make sure it's sealed so it's not going to have problems. But put it back together, poof, voila, you're done. Okay? And the other thing I should say is when you use a full wave rectifier like this with a pigtail, which is soldered into this, you just put it together. If you want the information, call me, or I can point you to the site where they actually show you how to do it. When you hook it onto here like this, you can do all the strings. But the problem you'll have, if you have 50 strings, and they're 50 and there's 2 circuits to each one, guess what? You got to switch all of them. So it kind of does lock you into where you got to use this.
Hey Dennis?
Yes, sir.
So you've mentioned the situation where you've got the wart on each end. So what's going on when you've got, like, some you'll have a wart on each end, maybe 1 in the middle, sometimes you've got like 2 in there, so you've got anywhere from 2 to 4 warts that are on a string.
Right. You'll have, yeah, 2 to 4 would be a good way to put it. Sometimes you might have 3. I don't think you'd have 3, but you probably, I'd say it's either 2 or 4. What I'm saying that is if you get 100, there's going to be 4. If you get 75, there's going to be 2. Because remember, if we did the math out, we have 170 volts. If we have 2 volts, 3 volts per shot, we need to use up this to get it to work. So if we take, how many times does 3 go in 170?
58.
58?
Yeah.
58?
Okay, now you're starting to see what's happening is why you see 35, 70, 100, and why you see more words on there. That make sense? As we're eating up our power source. And and other thing to point out, why I was telling you to steal these from your ex-wife, people you do not like, or people that do not prescribe to Christmas lighting programs, is it's got a 3-watt fuse in it. And we all have these laying around, these fuses. If you guys don't have a bunch of them laying around, call me. I've got a whole bucket full of them. But what's really sweet is when you do any of these modifications, you do anything, we are working with power. Be very, very careful of what you do. If you do not feel comfortable with it, don't do it. Because this could end your life. You know, so be careful with it. But I'm not trying to scare you, but I'm trying to tell you be careful when you do this kind of stuff. But this is why it has a 3-watt. And that's why when you see a bridge rectifier, the one that they use, this one's 400 volt, 3 amp. It's 3 amp fuse. So if this goes wrong, what's going to happen? Burn my fuse up before it burns anything else up. Okay? That's why I like these cords. That's why you cut them and save them. Okay. On the glob issue, it's real simple. To build these, once you know the voltage, we know the forward. Actually, what you need to know is you need to know the forward voltage. You need to know the milliamps drop. And then you can pretty much get everything else in line. What it'll do when you run into these programs, and they're going to tell you what kind of a dissipation that you'll have in a resistor. What you'll see is this is a 2-watt resistor, which you're probably going to wind up with. This one right here. This is a 1/2 watt. But you can see the difference between them. Okay? When you see the difference between these, what it's just telling you that there's a lot of power that's just trying to dissipate. Okay? That's why people ask, just save your warts. Don't do it. If you get rid of your warts, get rid of them for permanently. Make your own up. Okay. When I made this string up, here is a wart that I made up. And it just uses the sheet. You can see the directional diode. You can see the resistors. On the resistors, you just need to add them up to get a certain chain. Now, you can use quarters and halves if you want. You can bulk them out, you can line them together, you can series them. But my concern is now we're going to have a work like this. So that's why I get these. As far as guys balking at how much they are, believe it or not, these were under 10 cents a piece. These are under probably like 5 cents a piece. Moser Electronics, you can order them from. But this took me 20 minutes to make up. What I did is I took this and I used an actual printed circuit board and I just cut it down. I haven't figured it out yet on how to, but all I'm going to try to do is take one of these and slice it so that I can have a bunch, and all I have to do is just plug them and solder them and do them. Way to do them is take a piece of pipe, put it over top. You pick heat shrink. I like pipe, plastic pipe, and just fill it up with either silicone, a good silicone to seal it, or hot glue, and then I have a good seal in there. Why I like hot glue? Believe it or not, if you're having problems, when it's coming out, it'll melt that glue. So you can visually walk around and look at your lights, they're hanging, and all of a sudden you see some glue dropping. It's like, whoa, that's getting hot. And that's the first sign something's going wrong. But I made this string up myself, and I think I lit it up already, but just to prove, because Pete's over here giving me the stink eye, that he doesn't think they'll work. But there you go, fellas.
Mm-hmm.
Okay, so what I'm going to do is I'm going to take this, and I used an actual printed circuit board, and I just cut it down. I haven't figured it out yet on how to, but all I'm going to try to do is take one of these and slice it so that I can have a bunch, and all I have to do is just plug them and solder them and do them. Way to do them is take a piece of pipe, put it over top. You pick heat shrink. I like pipe, plastic pipe, and just fill it up with either silicone, a good silicone to seal it, or hot glue, and then I have a good seal in there. Why I like hot glue? Believe it or not, if you're having problems, when it's coming out, it'll melt that glue. So you can visually walk around and look at your lights, they're hanging, and all of a sudden you see some glue dropping. It's like, whoa, that's getting hot. And that's the first sign something's going wrong. But I made this string up already, but just to prove, because Pete's over here giving me the stink eye, that he doesn't think they'll work. But And what's so sweet about this is that you can take these and now you could potentially make 4 lights, 10 lights. There's going to be a certain amount that you can't go past. But where you always, it's everybody's same issues. You get the lights up on the decoration, and it never fails. You always wish you had 2 less, or 1 less, and you can do it. Now I've made this in a series in a loop. You can make them, and I'll give you all the material to do it, how to do it, is where you can make them so the power passes through. But I just thought this would be a little easier to understand, instead of seeing wires going back and forth. And all we're doing when the power passes, we're taking power from here, shooting it at the ends. So this next string has our full force to work with. Okay? But that's how you modify LED lights. Okay. One of the other ones that was brought up was rope lights. This is an LED rope light. I got this one specifically for a decoration that I'm making, or looking at making. But this one can be cut in 24-inch lengths. If you look at it, by the way, they are hard to find. If you want links, call me or email me and I'll send you the link to the place. Very nice people. They do have, this is 3/8 they call it, but I think it's, what is it, Pete, 7mm or 5mm? There's a different millimeter, but it's smaller tubing. It's very, as you can see, it's very flexible.
It's a lot more pliable.
Yeah, if you're doing a decoration where you really need to get some good turns on, it's good. But this is LED light.
How many wires is that, Dennis? Is that
It's 2 wires.
2 wires?
Yeah. If you see one with 3 wires, I would not recommend using it for some of your decorations, because what it's going to do is not going to fade properly. It's more complicated. What they've done is they've got different lights that are inside of here, so you have different colors. If you take this string, you can look at this one. This one's got a cut mark right here, and you'll see a cut. It says 110/8, 110/20, and cut it. And this has already got the glog within the top of it right here, which this is something you can do, but the only thing you can't do is, I don't know, I haven't figured out how you could count up all the lights, but if you'll also look at these, they've got a resistor on each one of the lights. So that complicates it a little bit. So what I would do is, if you had problems, what I would do with these is ohm these, measure them what the power is coming out to DC, take a black marker that doesn't dilute, and write it on the back of this box. Because then you'll know what you need to have coming out here, and you don't have to do all the calculation. All you have to do is just reverse calculate it, and you can build your blob up to make it to that. But LED lights, guys, always kills me, and you guys have all seen them, where they'll have them all strung out, and what's wrong? One little section right in the middle doesn't light. Oh, that just absolutely frosts my cookies.
Mine too, actually.
Oh, I mean, I'm even seeing neighbors. My wife doesn't want to drive around with me anymore because I want to stop and go fix them. But what you do is, if you can get the same diameter, the same style of light, is you'll see cut points. Say if this gets washed off, if you look down the center of these, look through the center, as you'll see bulbs. Say, okay, you see a resistor bulb, but there's a space. Remember I was telling you on the cables where we have the 2 wires in the center? It's right here. You can take any one of those lights and you'll see it. They're either going to be on 18, 24, and now it's 32. But these are smaller because of my decoration, which you can get them. But all you need to do is find that center point, and if they're burnt out in the center, it's perfect. It's telling you exactly where they're at. You clip it out. You take, I think they're an 8 or a 16 penny, not 16 penny. It's I can't remember the nail
16
size.
Gauge.
Yeah.
Probably
Like a brad or something.
A brad.
4-penny or 3-penny nail.
Yeah, and just clip it, and what I've seen the best is they do make caps, which actually they kind of look like that. I like, personally, is I clip them, I put it in, there's a glue called a CA glue, super glue. Okay, but they make different kinds. Where you can find it, if you can't find it at the store, hobby shop, A great place for it is lumber yards, lumber places, because they use it for high-end furniture. Take some of the CA, put your nails together and make sure it lights before you test it, and just push it together with the CA glue and hold it, and you got a seal. Maybe some clear tape or something around it wouldn't look too bad. But then you'll fix that section. And then next year you can adjust, put it somewhere else. But that'll help with the rope lights. Awesome lights. I like the ropes, but it is a little smaller. Now, the good news for us in the lighting industry is Dennis Cherry. You'll recognize this as the Lightkeeper Pro. Well, he's come up with an LED. I think it's called the LED Keeper Pro. I don't think they've come up with
LED Keeper Pro. It's something like that.
Yeah, it's a little different. But what it'll do, it's a godsend for us, because if you know LEDs, the way we used to check incandescence is with these. As you go along, you check every bulb. Basically, you just touch the bulb, and if you got power, you know you're good. When the one you're out, pull it, put an in-can in, you're good to go. Okay. You do that with LEDs, good luck. Because remember, you're not even enough voltage in there for this thing to pick up.
Mm-hmm.
So that's the problem. It's always been a problem. But there's a couple guys on PC that way back when did come up with kind of a solution. This is what they come up with. Basically, we have two batteries, 9-volt batteries. The thing that's kind of unusual about them is they're wired in series. Does anybody ever understand that?
You're adding them up then.
Yep. Right. So what are we going to come out when we're at the end?
PT.
Right. So what you'll see, well, instead of just wiring these, what you're going to see is that we're going to have our standard black, red to black, and red out. So it gives us a series circuit. That's what you'll see going through these batteries. Now, to protect the LED so we don't burn it out because we're putting too much volume through there, then you're going to see it's a 480K resistor on each side of the probes. And what I mean by probes, I've got a crude version here of this tester, but since Dennis has his coming out, it's going to stay crude. I'm not going to fix it up because I'm going to go by his. That's the best way to do it. But it just gives you something kind of example. We've got our set of string here. And what's impressive, that just about floored me, is once you get it laid out, you can go through and you want to hook on to the outward side of this bulb. I'll get it in here right. And voila. For all of you in the lighting industry, your heart should be thumping a little faster right now if you use mini LEDs. That is some cool shit.
That's magic.
Sorry my French, but
Yeah.
when you've pulled 500 of these dang things out because you can't figure out what's going on with it, that's a problem. Okay, there's no power. Dennis is basically is similar to this, but he's pulling power off a line, and he's just working. And he has the problem I have with this one is you've got a little switch to switch polarities.
So what you're not seeing is that string that's lit right now is not plugged into anything.
Nope.
But it's essentially being powered via the tool that's in Dennis's hand.
Yep. And you can make one of these up. Roger on PC is Oscom's Razor. Go search it and you'll find it. He's the one that come up with the batteries. I just got one of these testers, which I think is really cool. I mean, what's slick about it is you also has an LED light on the front of it, so it's telling me if I have polarity. So if one of these bulbs were burnt, you could back it up. But if I'm doing my 6 out, I get a light here, I know my wire's good. So I'm not worried about my wire, I'm worried about it is a bulb. So I go back and all you do, and the same way with Dennis's, how his is going to work, is you would just back up, don't do one at a time, but split it in half, try it, and it doesn't light, and then you can.
You know it's in that zone.
Yeah.
Right.
Yeah.
It does zone you in a little better.
Awesome.
And what's really slick with this one is if you have, to show you why this is really safe. Let's see if I get this one right the first try. So if this was, trust me, if this battery was too much for this,
You'd be gone.
go bang.
D-LED.
Yeah,
DLED.
DLED. We're starting a new club, the non-DLED people. Okay, but that's what's showing you. And what we did is we got 6. You can go out to about 7. And what you'll do is it's kind of neat too. Is you get like 7 or 8. You'll watch the light. It'll kind of it's just barely coming on. You're getting at the end of the battery power. So then you just have to reset. But I would recommend that everybody go get one of those. They should be out, I think, at the Academy in Houston.
Yeah.
They're supposed to, Dennis, that's his big unveiling. But I've got 3 of them on order, so that's really slick stuff. You can also make one up too.
But you need the hat pin, right?
I will go in and get into that.
Oh, okay.
That's highly technical. You can make one up off a battery pack too. So what you do is take a battery pack one. If you want to check, I haven't created, I've got it in my head, but I haven't created it yet. What I want to do is so I can take, it never fails, you get a bucket of lights, bucket of LED lights, and you're like, do they work or not? Is to create a little flat box or panel where you're not jamming something in that I can go by and stick it in. You can do these, and where Dennis has shown where you can do these, but understand, if you flip it this other way on this one, you'll burn your LED. So if there's any chance that this is going to burn my LED, I'm not going to do it. Because I will mess it up. I will put it in wrong. So what I'm going to do, what I like to do is create something that you can do that. And I'll provide it once I get something kind of built, and I can show you, or send it to everybody. On that, to impress your friends and neighbors, and this is actually pretty cool. I know Pete's just absolutely jealous because he didn't think of this.
It was in Make magazine 3 years ago.
Oh, it's been like 10 years ago.
Really?
Yeah,
Time
you could
flies.
actually buy it, you could get a kit where they'd send you a little
Right.
bag of them with a kit in it.
Yeah.
But I'm just showing you how you can go, you don't have to buy the kit, just go make your own up.
And they throw them up on stop signs.
Yeah. Stop signs, but what I like about them is you always got that one area where it's always kind of difficult and you want to shock somebody.
So what is that, Dennis, that you're putting together?
Okay, basically what I am putting together is I've purchased from Radio Shack an LED light, which if you have a string, say the cord's bad, something's plugged, or you got a good light on the end of it, you could use them too, but these are $3 for like 15, 20 of them. The battery can cost you $2 and some rare earth magnets. You want to tape it, tape it around so it makes it more secure. But the magnet portion of it's what's really cool is you can make them stick to things. And what I had some guys, actually I've done it, is you take steel wire and you take the steel wire and wrap it and stick it to the magnet, but you separate it and you go in your bushes and you just hang them there. So all you're seeing in the dark of the bushes is the green light or red light. Halloween's great. If you want to impress your wife, do it in the closet so they're just sticking out of it. And I'm telling you, it's sweet. But this
Looks
is
like a Jawa.
Yeah, there you go. But that's they call them throwies and that. Now back to Kevin's question on the high-tech piercing device. You will need these. And it's just a big needle. You could buy a couple of these. Some guys have told me that they like to use, I don't know the name of the pin, for diapers?
Safety pins?
Safety pin. Because you can grab it and push it. Why you need that? Because you can check your blobs. As you're checking your lights, unplug your cord.
Please.
Unplug your cord. I won't show you here because we can't see it, but put a needle in each side of your blob. Take your multimeter, hook it to each side of that. And you want to put it on diode test.
When you say put it into the blob,
Yeah, put the needle into the, put the needle into the wire leading to the blob.
Okay.
And some guys have said, oh geez, we're cutting holes all over in a wire and everything else. Well, you gotta realize when you pull that cord out and it hits the little sun, it's a little bit self-healing. So it's gonna probably close around itself. But when you push it all the way in, put your tester on diode tester, and then you hook it up to each side of the pins that you have on each side of the blob. Now, try it one way. Remember, it's directional. So flip it and try it the other way. If you get no reading at all, more than likely what's wrong?
It's open.
It's open.
It's
so
open.
It's no good. But you will, if you get a good blob.
D-blob.
D-blob. Yeah, there you go. I like that. I want to coin that one. You'll have a D-blob. But if you check it and you get a reading, that's telling you what? You've got a good
Blob.
blob. So now you've got a G-blob.
Yeah.
G-blob.
And a D-LED somewhere.
Yeah. So, but once you know that that blob is good, now when you get your reading on your multimeter, I'm telling you right now it's not going to mean crap, because you can't look at it to see what it is. So that number means nothing. All it's doing is telling you you're either good or you're bad.
Bad. Okay.
So don't take that number into if it's no equation. Okay, and here's more of a close-up of what that battery tester looks like and how it's configured. Remember, I don't have two with me, but there's two of the resistors. There's one on the inlet and there's one on the outlet. And then you configure your test whatever you want after that far as the wire goes. Okay, and then to make up your throwy, you just take an LED light with a few rare earth magnets and some tape, and you can have fun and impress your neighbors. And basically I think that's probably what we have.
Basically you've got this that you can throw and it sticks to metal.
And it's super cool. And then I guess we didn't show, and then here's another tester too if you wanted to see one. Which is mainly for testing individual lights, and it was just pulled off an old string. It's just got a start button if you wanted to check it. And that should cover it. Oh, and the LED lights too, to give you disparities. You've got one there. There's another one. Where did my little handy one go? What did I do with it? Oh, here it is. This one, Pete's gonna love.
Oh, it's got a little baby resistor on there.
Mm-hmm. Cool.
So you never know what you're going to run into or whatever model you're going to have.
And here's the high-tech wire
The high-tech
piercing.
wire piercing.
High-tech, yeah.
And the long lead's always your positive, and the short one's always your negative
Yep.
on those guys,
And
right?
then somebody else mentioned too that they said with the leads being aluminum or being steel.
Yeah.
Telling you now, they should all be steel. If they're aluminum, you all know that aluminum, the minute you clean it, it oxidizes.
And
that
you're
causes
done.
us problems.
Well, the steel's going to corrode anyway.
But the way you tell is that's how you're going to tell if you've got steel or aluminum. So if you're checking lights and you want to go, man, I'm sure changing a lot of bulbs. If you can take your light to a magnet and it doesn't do that, doesn't stick, then you know you got aluminum. And my probably recommendation was pull that string and throw it, because it's probably not going to be worth keeping. I think I've got everything. Pete, do you have anything to add?
Great job.
Awesome.
Good job.
That's it. Okay. And circuit boards test, I think we pretty well covered everything. There you go. Nice.
Thank you, Dennis.
Thank you.
Awesome.
Indeed. Good.